So boys and girls, let's move now to the colligative property called osmotic pressure. It is denoted by pi. Now what is osmotic pressure? It is the pressure which is exerted by the solution onto the solvent or by the concentrated solution to the dilute solution, so that osmosis stops. No more movement takes place from dilute solution to the concentrated solution. तो यहाँ से यहाँ तक का movement stop हो जाएगा, and इसी pressure को बोलते हैं osmotic pressure. You can measure that pressure at what pressure it is being stopped with the help of barometer if the piston is being exerted over there, and that is known as osmotic pressure. Osmotic pressure में एक और चीज आपको याद रखनी है, that mainly the movement you can change it from the concentrated solution to the dilute solution also. Is it possible? Yes. By applying more pressure over there. If you apply more pressure, then the movement is going to take place from the concentrated to the dilute solution of whom? Of the solvent. And the phenomena is known as RO. कहाँ सुना है RO का नाम? हेमा मालिनी की ऐड में Kent reverse osmosis. So reverse osmosis हो सकता है, yes, it is in the opposite direction, but then the pressure is going to be exerted more than the pressure which is attaining the equilibrium. तो opposite side में भी हो सकता है, but ये बहुत ही expensive procedure है. Japan is already doing this for what? For desalination of water. What is desalination of water? To convert the salt water into the pure water. So opposite direction में जा सकते हैं. Is that clear? तो यहाँ पे salt water concentrated है, यहाँ पे pure water movement इस तरफ हो सकता है, but over here the procedure is expensive. But you all have to know this is known as reverse osmosis. Definition मैंने लिखी हुई है. The external pressure which should be applied to the solution in order to stop the phenomena of osmosis is called osmotic pressure. तीन तरह के solutions होते हैं on the basis of osmotic pressure. If pi 1 is equal to pi 2, that means concentration of both of them are equal to each other, then it is known as isotonic solution. Like 0.9% salt solution, as I was telling you, is isotonic with your blood. Yes. तो ही आपको RBCs ना shrink होंगे ना they are going to swell. Hypertonic, hyper बोल रहा है, so pi 1 is going to be greater than pi 2. That means C1 is going to be greater than C2. तो अपने आप मालूम पड़ जाएगा. So hypertonic means high concentrated solution. अब एक एग्जांपल लेते हैं. फॉर एग्जांपल आपने मैंगो को, okay, mango you have cut down into pieces and that you have transferred into what? You have transferred that into the salt solution. Then what is going to happen? You are going to find that the movement of water molecules from that raw mango is going to take place into the salt solution, and that is what we call it mainly the osmosis. And which is hypertonic solution? Hypertonic solution over here is the one which is having more concentration, so that is going to be the salt solution. और movement हो रहा है from raw mango to the salt solution. उल्टा बोलोगे तो hypotonic हो गया. Hypotonic is exactly opposite of that, and that's why mango pieces shrivels down when they are going to be placed into the salt solution. So I hope this concept is clear to everyone, and this is known as osmotic pressure. So please copy it down. And take the screenshot also. Okay. Now we move to the laws of osmotic pressure. Very important with respect to numericals. Isotonic एक नया word पढ़ा, where pi 1 is equal to pi 2. Now laws of osmotic pressure. Now everyone knows there are gas laws, right? Gas laws, ideal gas, all of you have heard of. Now over here this is mainly laws of osmotic pressure related to pi. So सबसे पहले we all have to know solute particles. First point, solute particles behave same as gas molecules. ठीक है, तो solute particles behave same as gas molecules. Just remember this. And osmotic pressure of a dilute solution. Osmotic pressure of a dilute solution is equal to the pressure which the solute would exert if it behaves as a gas at same temperature and occupying the same volume. So this is just the concept. You all have to know that solute particles behave same as gas molecules. Who is solute? Mainly in solution. Who are gas molecules? Mainly the ideal gas behavior everyone knows. And osmotic pressure of a dilute solution is equal to the pressure which the solute would exert if it behaves as a gas at same temperature and occupying the same volume. Right? That means what? That means how the ideal gas has given you different type of laws, same way the solutes can also give you the different laws of osmotic pressure. It was given by the scientist called Van 't Hoff, and that's why the first law is called Van 't Hoff Boyle's law. Now this is for solute particles. So Van 't Hoff Boyle's law क्या बोलता है? That at constant temperature, pi is directly proportional to the concentration. That is at constant temperature. What is concentration is equal to 1 upon V. So pi is, इसका मतलब pi V is equal to constant हो गया. So Boyle's law था for gases P1 V1 is equal to P2 V2. यहाँ हो गया pi 1 V1 is equal to pi 2 V2 at constant